quadcopter drones for delivery. Students will be using the gold standard of project-based learning. Steps that students will need to follow for competition. They'll need the challenge of the problem, which is they're going to frame the challenge, the real-world problem. Sustained inquiry, it's the rigorous research of the problem and applying a solution. Authenticity, the real-world problem, student voice or choice. Their decisions of how to solve this problem. Reflection, write about the process and what they have learned. Critique and revision. This will come at the end, towards the end. And then, of course, a public product that will be done as part of the competition. The purpose of this competition is to make students aware of real-world problems and find solutions to these problems. Teams will use drones to deliver medication and daily necessities to residents in a community that needs to practice social distancing. Teams will need to deliver items in a timely manner and not cause disturbances, or we can say crashing into obstacles or causing some sort of distraction. Of course, the problem again is the coronavirus of 2019, COVID-20, harmful to many people, especially elderly and those with underlying conditions. Teams will need to research and build aerial drones, or buy one that's already, or get one that's already assembled. These drones will be provided for them. It's their choice to do the research on what they want and how they want it. The code of the drones must be written for the purpose of the specific drone's measurements and tasks to autonomously complete the task of delivering the aid. This competition, students will engage in quadcopter drone competition using both a remote controlled, which is automated, drone, or a coded drone, which is autonomous, to fly and complete missions. Students will create teams of two per team, two students per team. Teams will choose whether to use a smaller drone, which can only take one parcel at a time, but can use specific pathways to clear the obstacles, while the larger drones will be able to carry 3 parcels and need to hover on top of delivery zones to secure the sensor or make the sensor go off. Automated portion, of course, this is the remote control. The fly zones will consist of 5 houses, 3 grocery stores, and 1 hospital. The large drones will be able to just hover on top to set off the sensors. Smaller drones will deliver, but will need to travel underneath to set off sensors. They can fly by, while the other ones are going to need to hover to set it off. Autonomous drone students will construct and create their own delivery zones for fastest and best delivery method for each of their teams. So students will be able to engineer their own community deliveries. They still need to have the same amount of deliveries, same 5 houses, 3 grocery stores, and of course the shared medical zone. Barricades and obstacles will need to be placed in between those. Houses cannot be next to each other. An obstacle needs to be in between them. Through this, students will need to gather information such as distance, height, etc., to input their coding for these type of drones. The playing field. Teams will fly drones to accomplish the missions on a 50-foot by 50-foot octagon. It will be split up into 4 sections, each section, of course, having the 5 houses and the 3 grocery stores. 1 hospital store will be available for all teams, and it will be located in the middle. The outcome is expected for all students to educate themselves throughout the process of the competition in teamwork, research, documentation, mathematics schools, engineering, design schools, and about today's technology and its future advancements. All this in hope for students to understand the empowerment of a STEM or a STEAM education path and continue to evolve into a career or a trait for their future. The budget. Drones will typically cost around $250. This includes both do-it-yourself drones, store-bought drones, extra parts that will be needed for the design of the product. Volunteers will be recruited. First of all, this will include parents and students. Paid personnel will be paid about $20 per assembly for the competition zone. These volunteers and paid personnel will be responsible for making sure teams stay in their proper playing area and do not interfere with other teams. The playing field will cost about $500 to build. There's only going to be one large field, but if you go back and we see that field, 4 teams get to play at once. Buildings were about $50 per building, times $41, depending on the extra stuff that we have. It's going to be constructed out of cardboard and the motion sensors to activate LED lighting strips when completing a task or passing through a task. I've embedded a little drone competition so we can see what students will be envisioning. As you notice, as they took off, the sensor set off the LED lights. And then students are just going to be driving around. This, of course, is being controlled by remote controls. Just stop it there. Students and their teachers will write scientific inquiry paper discussing the use of drones for delivery. They will research and construct the drone and the parts that are need to be done to be successful. Teams will also include other ways a drone can help during a pandemic, such as the one of 2019. The teacher will provide aid and direction for any confusing material that a team might have and research that a student needs to inquire about. Sample notebook. So in the sample notebook, we've inquired different pictures, which will be laid out for their construction and how a quadcopter runs, what is needed for it, if they challenge to build it themselves, or even if they don't, they need to research it. They will use the project-based learning, the gold standard, which the delivery problem. To deliver food and supplies, sustained inquiry would be the research, the articles, libraries, professionals via Skype. Drones can effectively deliver and more while practicing social distancing. Authenticity, of course, this is, of course, because of the COVID-19. Students' voice, they're using their voice and how they can help achieve the assistance to people. They'll use a reflection, what they learned. Of course, they will critique and revision. And then the public project is a presentation to the audience. An example proposal projects. Here's a Tello drone. This is the one that I've been using. This is a picture of it. It is a smaller drone. Will be used in the small competitive drone. It will be used both in the automated and the autonomous portions of the competition. This drone is able to transport merchandise to customers quickly and safely while they are practicing social distancing. As a precaution of COVID-19, as teams will conduct our research. As a team, we will conduct a research and build our project based on the gold standard of project-based learning. Through this process, we will be able to frame our desired outcome from our learning and the competition. This project is not only about winning, but creating communication as a group member and learning for our 21st century future. The Talon drone is a small, fast enough to complete the course better than other drones because of the capabilities it has to be automated and autonomously controlled features. The only downfall of the battery is the drone's battery life. It will need to be landed at home base to get a changed battery. This will add time to completing the courses. So that is my design, its project, its proposal, and its competition that I would love to introduce to a school. While students get to build their own or do their own research, they get to do the whole gold standard of project-based learning, research. They get to do so much. They interview people and see what works best for them. Thank you for watching my video. I appreciate it.